In section 2, we're going to take a look at reflection. So if you remember from section 1, a reflection is flipping a shape without changing its size. And we're going to take a look at two types of reflection. The first being the reflection over a line. And the second one being a reflection over a point. So when we talk about a reflection over a line, we're talking about three different lines. We are either going to reflect over the x-axis, which is the line y equals 0, the y-axis, which is the line x equals 0, or the line y equals x. And anytime we reflect a point, a shape or a point over a line, each vertice of our new shape is the same distance from whatever line of reflection we used. So in here we have three different examples of triangles being reflected across our three different lines. So the y-axis, which is a horizontal reflection, the x-axis, which is a vertical reflection, and then across the line y equals x. We also have the reflection over a point. And when we reflect over a point, we're going to use the origin, which is the point 0, 0. But you can also reflect over any other point as well. And just like when we reflect over a line, each point of our vertice is the same distance from our reflection point. So in here we have the shape or the triangle ABC reflected across the point P, and each vertice is the same distance from that point P, the original and the reflected triangle. So the rules for reflecting about lines and origin. So when we reflect across the origin, the points on our original shape, they get their opposite sign. X and Y become their opposite. So X and Y get their opposite sign. When we reflect across the x-axis, Y gets its opposite sign. When we reflect across the y-axis, X gets its opposite sign. And then when we reflect over the line Y equals X, we switch X and Y. So we're going to use these rules to do some examples. So we're going to find the transformed points and sketch the original shape and our new shape. So we have the triangle ABC at points 2, 2, 3, -5, and -1, 0. And we want to reflect it across the x-axis. So our rule for reflecting across the x-axis is we take our point xy and it becomes, the x stays the same and the y gets its opposite sign. So our point A prime is going to be at 2, -2. Our point B prime is going to be at 3, 5. And our point C prime is going to be at -1, 0. So we can't make 0 have its opposite sign. So anytime you have a y coordinate that is 0, that point actually isn't going to move when you reflect it across the x-axis. So let's go ahead and draw the original triangle. So the point A is at 2, 2. Point B is at 3, -5. And point C is at -1, 0. Our new image, the point A prime is at 2, -2. B prime is at 3, 5. And our point C prime stayed in the same place. And if we were to draw a dashed line between our original points and our new points, you can see that they're the same distance from that x-axis. So our next example is the triangle ABC with points 1, 3, -2, 6, and 0, 0. And this time we are reflecting across the y-axis. So the rule for the y-axis is each point xy, we make the x-coordinate have its opposite sign. So the point A prime is going to become -1, 3. The point B prime is going to become 2, 6, and then the point C, 0, 0, is going to stay at 0, 0. So when we graph our original triangle, we have A at 1, 3, B at -2, 6, and C is at the origin. Our new image, A prime is at -1, 3, B prime is at 2, 6, and our point C stays at the origin. So this time you can see, again, if I were to connect the original and new shape with horizontal lines, they're directly across from each other and the same distance from the y-axis. So next we have triangle ABC, and we're reflecting it across the line y equals x. So the rule for the line y equals x is that xy, you switch x and y, so it becomes yx. So my point A prime is still going to be at 0, 0, B prime is going to be at 2, 5, and C prime is going to stay at 4, 4, because when I switch x and y, I get the same point. So the original triangle, A is at 0, 0, B is at 5, 2, and C is at 4, 4. Our reflected image, A prime is going to stay at 0, 0, B prime is going to become 2, 5, and C prime is going to stay at 4, 4. This time, if I want to see the reflection, I need to actually graph the line y equals x, because that's where we're going to see the reflection. So with the line y equals x, because it goes through the points of A and C, they stay in the same place, and then our points B and B prime are the same distance from that line y equals x. So our last example with the graphing, we have our triangle, and we're reflecting it across the origin. So for the origin, the rule is that our points x, y become negative. So -x, -y. So the point A prime will become -2, -2. Our point B prime becomes -3, 5. And then our point -1, 0 for C becomes 1, 0. So every point gets its opposite sign. Not necessarily does it mean that they all have to become negative, because if the original point is negative, its opposite sign would be a positive value. So when I graph my original triangle, we have A at 2, 2, B at 3, -5, and C at -1, 0. Our new image, A is at -2, -2. B is at -3, 5. And C is going to be at 1, 0. So when I connect my vertices for my original and my new image, this time the reflection isn't a line, it's about the origin, this point. So each of our new points is the same distance. It's been flipped across, if you will, kind of think of it as a flip. It's been flipped across that point 0, 0, so it's kind of crossed it. Some of those are diagonal, some of them are horizontal. It just depends on where the point was originally. Okay. So our last examples, we're going to determine which line or point the following shapes were reflected over. So we start off with our first picture. We have a quadrilateral VFKJ and our new image J prime, V prime, K prime, F prime. So it's not necessarily going to be reflected across our x-axis, y-axis, or origin. It looks like it's reflected across a different line. So if I look, each of my points is the same distance from the line y equals 2. F to F prime is 1 away, K to K prime, V to V prime, J to J prime. So in this case, we've been reflected over the line y equals 2. Sometimes we can reflect across vertical or horizontal lines, which are still similar to the x-axis and the y-axis, because those are vertical and horizontal lines. Okay. In our last example, similarly, we have our quadrilateral, and each point is the same distance from the x-axis. If I were to draw all of my lines connecting my vertices, they would all be the same distance from the x-axis. So in this case, the reflection is the x-axis, which is the line y equals 0. So as you're working on the assignment over reflections, let me know if you have any questions over the different rules we've discussed or how to identify what type of reflection you have given an image and its reflected image.